Okay, we'll leave it on the screen here. So this is part 2 of this, and so here we go. The long jump. This is the fun part, the long jump. Watching people do it. I can't do it at all. But here comes the the physics part, where you have a horizontal component taking off this way. Horizontal, let me get horizontal and vertical correct. Here's the horizontal component, and here's the vertical component taking off. All right, and then you add those two vectors, and the vectors change as you go through the path. Topics, things you need to know about when watching a projectile motion or doing projectile. The center of gravity, projectile motion. Those are the two things that are needed, that are required in the long jump. Center of gravity. All right, center of mass, center of gravity, same thing. Center of mass we use more. Center of gravity we can use here on Earth because the gravitational pull on everything is the same. Where an object is seems to be a simple question, but for example, you may ask, where exactly is the person? What should I answer with? Okay, is it their head? Is it their hand? Is it their arm? What part? Well, we look at perhaps maybe the center of the person? Maybe. Okay, so we look at the center of mass of objects. What if we had this object? Where's the center of mass? Here's how we do that. Or this. Ooh, this is interesting. Where's the center of mass of this object? Center of mass, Jim, here's one way to do it. You hang it from a string. Hang this object from like point A right there. Draw the line, the dotted line, straight through. Now, we're going to hang it from this point here. Draw a line straight through, and the center of mass of this object will be where those two lines intersect. That's the center of mass. Okay, center of mass, geometrical method second. So baseball bat. Draw a line. If we were balancing it on our finger that way, or that's where the center of mass would be. Then balance point. And then we're going to balance it on our finger. Draw that line straight through there this way. And right there in that fleshy part, about 2/3 of the way down, is where the fleshy part of that bat is. It gives us the center of mass. Question. Where's the center of mass on this object? It's right there. Center of mass doesn't have to lie on the object. And if you think about it like a hula hoop or a wheel, you know, where's the center of mass in a round shape that's hollow in the middle? Well, the center of mass would be where, remember, the center of mass does not have to be located on the object. All right? Center of mass for people. Okay? Right about there. It's where the W does not stand for whiz. I'm sorry. But that's whenever I show the slide, that's what I think of. I can't help it. All right. There's the force pushing up, the normal force pushing up, and then the weight pushing down. Now, if they get that weight, that center of mass over right here, if they get their center of mass over their base of support, they could fall down. But actually what happens is, if you get your center of mass over your base of support, in this situation, where you've got your center of mass above your base of support right here, where this is your base of support. Now what happens in a human being is your back muscles, your lower back muscles contract and hold you up. This is why if you're working at a table that's kind of low and you're bent over working at the table, but your feet, you know, like you're working at the table right here, your feet are back here and you're bent over like this, gosh dang it, I'm sorry, you're reading my text. God dang it, son of a, please go away. All right, so anyway, so there you go. That's why your back starts to hurt. Sorry about that. On average, will be about 1 inch above a 6 foot tall woman. Okay? So it's about 1 inch higher. So the center of mass for men is higher than it is for women. Of course it is. Men don't have to have babies. Now, where's your center? So I want you to try this little experiment. Where's your center of mass here? Now look, his center of mass is probably right about here in his body, but he's stretched himself out, so the center of mass might be down around here. Try and stand up from your chair while you're sitting there in your chair, and then I'll stop this little segment. Try and stand up without moving your feet underneath your chair. In other words, have your feet just be sitting. I'll show you what I mean. Just be sitting, leaning forward like that, not leaning forward to stand up, which is the way you do it. Just try and stand up just right here like this. Oh, you can't do it now. I got my center mass here. You gotta lean over, stand up, and get up. All right. So that's what we're projecting. We have to project that in the projectile motion of the center of mass. Okay? All right. We'll stop here.